Hello, my name is Rathanak. I am an electrical engineering at Rajamagala University of Technology Isan, and I IEEE PA student too, and also an apprentice student at Hitachi Energy Thailand Limited. Today I would like to present about my project during my internship is Smart Digital Substation, Standard Connection Code, Review Design and Result Analysis for Online Monitoring System, Case Study, Sattahip 2 Substation, the Royal Thai Navy Welfare Concession. And during my internship, I am under caring and supporting by Dr. Pradipung Suksirithawongkun. He is an IEEE Senior Membership Secret Member, Senior Professional Engineer, Council of Engineers. And these are contents that I would like to present, such as Introduction to Digital Substation, why switch to online monitoring of power transformer. Why need an online monitoring system for power transformer and the online monitoring of power transformer and thermistor? Analysis the consequence of online monitoring system and case study 115 kilovoltage Sattahip 2 substation, the Royal Thai Navy Welfare Concession, and the last one is summary and recommendation. And this is the feature of digital substation using standalone matching unit that utilize such 100 process back input-output to collect analog current and voltage signal from the instrument transformers such as CT and VT from switching equipment and digitize this analog signal to that digital signal over IEEE 31850 to IEDs for protection and controlling the substation. Moreover, it has the online monitoring of power transformer for supervision and do asset performance of power transformer for predict the aging of its operation. On this page, we can separate clearly the difference between digital substation and conventional substation. The conventional substation, we can see that there are a lot of wide point-to-point connection between switching equipment to protection and controlling delay. But the digital substation, it uses fiber optic connection between switching equipment to protection and controlling delay. We can see that the consequence of digital substation is reduce cabling defect and make more reliability and safety for substation. Negative 10. Why switch to online monitoring of power transformer? During the operation of power transformer, there are always stress that to trouble power transformer such as weather event, system fault overload, or switching event that to reduce aging of power transformer and outage without planning. So with the online monitoring of power transformer, so by this curve, so that with the online monitoring we can plan in offline of power transformer, we can predict the occur event which happen in the future. With the online monitoring of power transformer can solve all these problems such as dehydrating results, no silica gel visual inspect and reflect by automatic silica gel regeneration process. Like pressure relief with the online system, we can continue pressure monitoring available alarm threshold, which means that we get alarm signal before the transformer. And with online system, thermistor, we can check and monitoring the capacitive and resistive leaking current, and we can analyze the current in power curve too. And like the oil of on-load tap changer and transformer oil, we only use the digital sensor to dissolve analysis for gas instead of take oil sample to the laboratory. For checking the internal fault, for predict the aging and predict the occur event of transformer. We can see that any kind of fault such as cellular aging, leakage into oil, thermal overheat, thermal fault, partial discharge, and aging are always represented by any kind of gas, but the notice is all of the fault always represented by hydrogen and water. So it is the main reason of choosing the digital sensor for suite of transformer, and we'll talking on the next content. The next one is why need an online monitoring system for power transformers? So with the online monitoring of power transformer, we can monitoring it by 24/7 hours, and we can get live data of power transformer for planning, detection, and maintenance from any failures. So the output is minimal maintenance, make safety, reliability to system or power transformer, and mitigate of any fault and provide the transformer in operation without any disturbing. And then they contain the online monitoring of power transformer and service. The T-Expert ecosystem is the digitalization technology of power transformer were designed to drive data-driven, intelligent, enable continuous monitoring and decision making for operation and maintenance of power transformer and power grid. The T-Expert TM is covered from implement the EDY or digital sensor, consent sensor of on-load temperature, T-Expert BM for monitoring the bushing, and all these sensors are monitoring the status of transformer and transfer the data to contact fault. And these data are taken for analysis through APM, Asset Performance Management, or transmit to user interface or SCADA for analysis and predict the aging of power transformer. As I mentioned above, the functionality of contact fault is a modular transformer monitoring system designed to collect, aggregate, and analyze data for a single transformer and monitor the power transformer from different sensors such as top oil temperature, diesel gas, load operation, the position of tap changer, the aging of bushing, and from other digital sensors such as e-device, and get the data is from any sensor for store data for calculate hotspot temperature, aging rate, and set overload capability for controlling fan efficiently to maintain oil temperature within the set limit for power transformer working in full load. Concession TF is a single gas sensor that sensitive to hydrogen and moisture and divided to two solid state. The first one is solid state hydrogen sensor use an oil image that sensitive to hydrogen, and the second is solid state moisture sensor use an oil image capacitive sensor. And this is the effect of constant single gas sensor, and it provides hydrogen and moisture concentration in percent or part per million ppm. And this is the location of constant TM single gas sensor installed on power transformer to allow hydrogen and moisture percent to user interface to contact fault. For analysis the concentration transformer oils that the quantity of hydrogen and moisture is in good condition or exceed the limit. Constant TM M10 is the same interface as constant TM. It is the multiple gas sensor for diesel gas analysis such as hydrogen, moisture, and the eight type of gas such as methane, acetylene, ethylene, ethane, etc. The constant TM M10 need only one plate required that compared to or the manufacturer needs to plan require. So Concession TM-M10 is very low risk of oil leak and no ethanol over circulation. And these are the detox sensor. It is the e-device that implemented to power transformer in order to acquire the real data for online monitoring of power transformer. And this data monitoring is offered through a 4 to 20 milliampere analog output and Modbus RTU RS485 communication protocol. Transformer bushing failures are often occurs to power transformer, so it is the high interest to transformer asset owners. And with offline testing, it's always performed in outtake, so the power transformer cannot be continuous lease operation. And this is the TM bushing monitoring that implemented to advise of high volt bushing and connect to contact 4 through communication protocols such as Modbus, NDP3, IEC 30870, and IEC 31850. TM on-load temperature monitoring. We can monitoring temperature differential that relate to temperature of main tank and temperature tank oil. Under the normal operation temperature will not generate much heat, and its oil will be heated by contact with the main tank. And monitoring changing in temperature because when it too frequency is changing, causing motor to work harder, but when it too long in the same position and can causing the contact wear. And the last one is monitoring the number of operation because when it exceeds the limit, the operator must be take maintenance on load temperature, and the number of operation is based on design of manufacturer. The next one is pressure relief device for continuous pressure monitoring by 4 to 20 milliamp Modbus RTU. When we compare to conventional system, the online monitoring system can available alarm threshold before the power transformer. The next one is cell dehydrating pressure. It is replacement by silica gel. Its functionality as automatic silica gel regeneration process for absorbing hydrogen and moisture from on-load temperature and main tank. And it has two types, one tank inside and two tank inside. With the two tank inside, it have each other working. It means that if the first tank is working, the second tank is open. But when the second tank is working, the first tank is open. And this is the interface of contact 4. We install it in local cabinet box. And it is support many protocols such as Modbus RTU, Modbus IP, etc. as so on the page. And it can operate ambient temperature between minus 40 degrees Celsius to 60 degrees Celsius. And using communication interface such as RS485 series port, RJ45 100 BST, ethanol port, etc. The Cortex TM4 is collecting the data from many accessories such as oil level indicator, temperature indicator, reserve relay temperature, and constant to Cortex 4 for monitoring and diagnostic and controlling. And this data are transferred to user interface or SCADA for analysis, asset here, monitoring to optimize operation and maintenance of power transformer. TSPAD TM APM is the software that collecting data from history data from factory test report and online sensor to configure to the software for analyze the health of power transformer and predict the occur event in the future of power transformer in order for power transformer operation with efficiency without any disruption. The Country A is the device for surge control monitoring that implemented after surge restore for protection power transformer from lightning, temporary voltage, and switching event. And this is the location of the Country A for getting real-time remote monitoring, concept with amplitude steepness and timestamp, and continuous monitoring of electric current, resistive electric current, and surge current impulse for analysis the impulse curve and predict the operation of surge resistor. And the next thing is analyzes the consequence of online monitoring system of power transformer and surge resistor. And this is the homepage of online monitoring softwares that allow us with thermophone, cooling time, DGA, bushing, on-load temperature, safety device, and accessories that collect from contact form. And this is the parametric status card that allow us with many data such as oil temperature, hot spot, load, bushing, DGA, oil level, and aging of power transformer for predict the health of power transformer and provide real data and continuous monitoring 24/7 for the operator make right decision making and can predict the occur event in the future. And this the TSPAD-TM subscript that provide from production icon bar such as home, along with dashboard, thermophone that visual temperature, aging, and overload, and cooling status, cooling, DGA provide with the value of gas, TDCG staking, and analyze the dissolved gas by any method such as the wall triangle, Roger radio, IEEE, or IEEE. Bushing visual the scan and data by online on-load temperature, along with status and protect wheel, and safety device and accessory visual the measurement from any digital sensor that we implemented to power transformer. The TSPAD Hub Cortex 4 software version 2 is collecting information from various sensors and data point, display them with parameters defined by the user, and these parameters are configured within the device descriptor page of the user interface. The user interface also defines critical running and operation threshold for event reporting, and define threshold as alarm state 0 is the low critical threshold, low running threshold, and state 2 is operation threshold. Alarm state 3 is the high running threshold, and the last one is alarm state 4 is the high critical threshold. And with this event report, allow the operator with information for consideration and make right decision of the power transformer. Example like low and high running. The operator must check the system and find the reason what's wrong with this parameter display. And the low and high critical, the operator must take suddenly maintenance to power transformer is still continue operating. The power transformer can be fairless. At this thermal icon bar is divided into 4 subscreens such as measurements, temperature, aging, and overload. And on this subscreen measurement display bottom and top oil temperature. At this value point, the power transformer can continue as operating, but when it is nearly the critical point, 110, the operator must be suddenly change the main reason why causing it is nearly the high critical point. On this temperature subscreen, it provides the operator with this value such as average fluid temperature is the temperature oil, high volt, low volt, and titrate temperature it is the transformer winding temperature, and hotspot temperature it is the value that calculating by ambient temperature and top oil temperature, and it is the low critical points, normal operating, is the high running point and high critical point. All the value point it is in normal operating except hotspot temperature. It is in high burning point, so it can easy to make for the operator make right decision and consideration and find the main result that and solve with this problem. Aging factor is affected by the hotspot temperature. It usually taken in investigate the aging process with the hotspot temperature. It means that it is loss by of high volt, low volt, and tertiary winding of power transformer, and aging factor value represent time in hours. Smaller number are better, and the top oil temperature is at the critical point, so the operator must be suddenly check the power transformer and solve this problem. At this overload subscreen, can configure the top oil temperature, ambient temperature, maximum hotspot temperature, and cooling capacity, and set the overload step and update. For example, at the 107% of overload, we can continue operating the power transformer 4 hours, but when it exceeds 4 hours, the power transformer will strip for protection. The power transformer avoid from any failures to power transformer. On this cooling screen, there are 3 types of cooling group, group 1, group 2, and group 3, and it shows 3 parameters. Date of last maintenance, it is the date of maintenance, and since last maintenance, it is the time of last maintenance, and total time, it is the total time from conduct until operation day. On this control subscreen, we can configure the cooling group and auto configuration of cooling group by config top oil and hotspot temperature and select the first group and the last group, and configuration of cooling group by config the stop and start of top oil temperature and hotspot temperature and select the group of cooling. And this is the result gas analysis of power transformer. We will analyze the 8 types of gases such as hydrogen, methane, acetylene, ethylene. All these values provide from constant and multiple gas sensor, and the quantity of concentration of gas present in part per million ppm, and the config value based on IEEE method that divide into 4 conditions: condition 1, condition 2, condition 3, and condition 4. Condition 1 is in normal operation. Condition 2, fault may be present. Condition 3, fault are probably present in this condition, so it needs immediately investigate. And condition 4, the total dissolved combustible gas exceeding this value. So if we still continue operation, the power transformer can fail, and it needs immediately check and maintenance within the caution. On the DGA syndrome, TDCG staking stands for total dissolved combustible gases. It provides from summing of concentration of any gas in transformer oil that represent in part per million volume. And with this interface, we can check the past 24 hours, past week, and past month of total dissolved combustible gases. Double triangle is the method of analysis the internal fault of power transformer. Triangle 1 for analysis low energy fault. Triangle 4 and triangle 5 to analysis high energy fault. From triangle 1, we can see that it is represented by T1 thermophore less than 300 degrees Celsius. Triangle 4, it represented by C hotspot, and triangle 5 at this point represented by O overheat for less than 250 degrees Celsius. And these are set type of fault detectable by DGA. PD partial discharge of the corona type, D1 low energy discharge, D2 high energy discharge, TD thermal fault of low temperature less than 300 degrees Celsius, T2 thermal fault 2, but limit the temperature between 300 to 700 degrees Celsius, and T3 thermal fault of high temperature over 700 degrees Celsius, and this is the subtype of thermal fault. Example O, it stands for overheating of oil or pepper at temperature less than 250 degrees Celsius. And this is the diesel gas analysis by Rajamagala method. And we can analyze this by this graph. On this interface, we can see that it is represented by high energy discharge action. And we can analyze this uniform by representation of cube block on this curve. But if we want to make sure we can to compare with the theory radio standard of Roger by this table. Diesel gas analysis by IEEE gas ratio is represented by cube block, and take the series radio gas for analysis the internal fault of power transformer such as partial discharge, low energy, high energy, and thermal fault. And the data information we can transfer by checking the radio table of IC gas radios. So for analysis the internal fault of power transformer, the reason why we do by many methods such as the wall triangle, radio, IC gas radio to make reliability efficiency for analysis the internal fault. And with this online monitoring of transformer oil, it provides us what internal fault will happen in the future, and we use time to take oil sampling for diesel gas analysis at the laboratory. Bushing online monitoring. On this display screen, there are two sets of bushing that measure high volt phase A, phase B, and phase C. Measure the capacitance, leaking current, and time data of high volt bushing. The limit value is based on drawing design of power transformer that configured by the operator. Capacitance and time data are recognized as some of the main diagnostic parameters of bushing isolation condition. Since these two parameters are directly impacted by degradation of the insulation. For example, layers of insulation short circuit cause capacitance to rise, while in trend of moisture because of sealing failures cause time data to increase. And the online monitoring of bushing allows for capacitance and time data. For protection, the power transformer from overvoltage and overcurrent caused by transitory phenomenon in the grid. On this on-load tap changer status, it shows the position contact and its operation time, current position contact, adjacent position, diverter contact, and date of last switching. Moreover, it shows the total current position for diagnostic, the degradation of on-load tap changer contact. On-load tap changer contact will display on Cortex TM4. It shows the number of operations remaining to service for that to service or maintenance the on-load tap changer, and the number of operations remaining to contact exchange for exchange the contact of on-load tap changer. and the number of operations is based on the drawing design of on-road passenger or from the manufacturer. And this display value it makes easy for the operator to plan to maintain the on-road passenger for power transformer to energize power continuously for load. On this safety device screen, it shows the value of safety device. We can add more value by click the add symbol and category mapping and update. It will show on the screen. And on this screen display, it shows the oil temperature indicator and oil level. And by the value, it divides into 3 steps: low critical point, normal operating, and high critical point. And all this value shows it is in normal operation. And the value that config to monitoring is based on drawing design of power transformer. Accessory screen display on Cortex TM4. It takes from category mapping from accessory such as top oil temperature, ambient temperature, and transformer current. And with this value, the operator config by 5 stats such as low critical point, low burning point, normal operating, high burning point, and high critical point. And so with this online monitoring, the operator can diagnostic by 24/7 of power transformer. And this is the last one of analyze the consequence of online monitoring set register that implemented account 3A to provide concept with amplitude, stepness, and timestamp, leaky current, residual leaky current, and set current impulse by register set into cent that interval, and we show the total set with maximum and minimum set amplitude. With all this data, it is easy for the operator diagnostic the degradation of set register by comparing the value between residual leaky current and maximum recommendation residual leaky current standard. The next content is case study 115 kV Sattahip 2 substation, the Royal Thai Navy Welfare Concession. This is the SCADA system configuration of the first digital substation in Thailand at Sattahip, Chonburi province. With the case study, I have studied the high volt part that VT display is SAM 600 that taken the current and voltage signal from CT and VT and connect to SAM input-output process bus for changing the current and voltage signal to digital signal through SAM power value protocol to relay for protection and controlling. And each of protection and controlling relay is communication to each other by GUS protocol, and it is transmitted to user interface and SCADA for checking the occur event or undefault event of the system. And each way it has two protection relay for primary protection and backup protection. And this part, it is the online monitoring of power transformer that taking the data from third counter, Concession and Cortex TM4 to user interface by fiber optic communication. And this is the 2 unit of power transformer rated 50 mega VA. And this is the location of each device. EPRD pressure release device. It is implemented of on-road passenger and maintain. Concession TM. Account 3A. Cortex TM4. It is in the local cabinet box. Buffer relay. Oil temperature and winding temperature. And oil level indicator. There are all the sensors that utilization to Sattahip 2 substation, except Concession M10, and all the sensors connect to Cortex 4 by Modbus RTU RS485 to Cortex 4 for diagnostic the aging of power transformer. On the home page of Cortex TM4 of case study, it doesn't display upload hotspot temperature. So the main problem is maybe the current from CT of power transformer cannot consign to Cortex TM4. And for bushing and aging of bushing, it doesn't display because at this substation, it doesn't consist of this sensor. And at oil level, it may be oil level of main tank and on low temperature, and on DGA, it analyzes only two types of the gas because it has only constant single gas analysis. On this thermal measurement, there is no value display because there are some problems that to thermal sensor does not send the signal to Cortex 4. On this thermal temperature, we display the average fluid temperature, high volt, low volt and tertiary, average temperature, hotspot temperature and ambient temperature. And the limit value is based on the configuration of drawing design of power transformer. And the average temperature does not display because maybe 4 to 20 milliamp signal of thermal sensor connect to Cortex TM4. And hotspot temperature, it declines top oil temperature and load current of power transformer to calculation. The thermal aging factor is display of high volt, low volt, tertiary aging factor, make cumulative aging factor and top oil temperature. Top oil temperature is in normal operating. Cumulative aging factor is the measurement value of accumulated calculated aging of winding since the monitoring system conduct. Aging factor value represent time in our smaller number are better. And this value did not display because it requires aging calculation that relate to hotspot temperature. So the main problem is the 4 to 20 milliamp signal of CT of power transformer connect to Cortex TM4 for calculation. On the thermal overload, we cannot be set continuous overloading because there is no make hotspot temperature for config to set the overloading. So the main problem is the same above problem. DGA level, it display only hydrogen and moisture because it has only constant TM single gas analysis and divided into 3 steps: normal operating, high running point, and high critical point. And on total, dissolved combustible gas stacking, dual tangle, Roger, IEEE ratio, will does not display because it does not consist constant TM10 for multiple gas analysis. On safety device, it display of gas accumulation of polylate present in centimeter cube, oil temperature indicator, pressure relief device of on-load temperature and main tank, and discrete winding temperature. And divided into 5 steps. First, low critical point, low winding point, normal operating, high winding point, and high critical point. And all these values are in normal operating point. Accessory, it shows the oil level, indicator of on-load temperature and main tank, and make level, min level, show the maximum and minimum level per day, and set the hydrating result utilized for absorbing the moisture from on-load temperature and main tank. With the number of minus 100 degrees Celsius, it may be the wrong number because at Sattahip 2 substation, it implemented with set the high better 1 tank, but maybe when we configure it 2 tank, so it will display wrong values. And by this value, the operator config with 5 steps. The first is low critical point, low winding point, normal operating, high winding point, and high critical point. And all the data are in operating point. And account 3A, it is the location of account 3A smart monitoring of cell register, utilized for diagnostic degradation of the resistor for protection the power transformer. It is the interface of account 3A online monitoring by register set instruction that interval and it will show maximum and minimum set amplitude, total set, make peak and front time. And when we click at this point, it will show the timestamp and current impulse curve. By choosing data interval, there are 4 set impulse. The first one is happened on 19 December 2020 with time occurs, make peak and time rise. And the third current impulse waveform occurs on 21st December 2020 with make peak 75.9 ampere and rising time 0.38 microseconds. And the last one is with make peak 347.1 amperes that occurs on 17 September 2021. And this is the positive electric current of 488 impulse amplitude. And it shows electric current at 0.5 microampere. And we will take the positive electric current to compare with maximum recommended positive current. And this is the equivalent of the resistor and maximum recommended positive current. By the variable, we can compare with this curve of any product of the resistor so that it's less than this recommended maximum of resistive current. So the set resistor of Sattahip 2 substation, it is in good condition. The last point is summary and recommendation. Digital substation according to the IEEE 31850 standard being coefficient, reduce the number of wires, reduce the footprint by decreasing the control and protection relay, reduce on-site testing and commissioning by switching to fiber optic cable, contact TM, the key parameter to warn the operator of the accelerated aging condition and activate the caller sooner than a conventional system. The limitation of the temperature execution, the third current condition can be provide an overview of short-term overload capacity, which allow the operator to consider the power transformer aging versus increase throughout and revenues. Moreover, Cortex TM4 can implement it with a 6 transformer to track and run below recommended critical limit will have a predictable occur event will happen. And moreover, an online monitoring system can avoid unplanned outage by continuously measurement on temperature, load, and gas forming in real time. For the power transformer operating without any disturbing. Recommendation: need to check the CT signal of power transformer to ensure the load current signal to contact TM4 for calculation, hotspot temperature and aging factor. Should set identifiable name of safety device and accessory such as self-dehydrating of on-load temperature and maintain oil level of on-load temperature and maintain. Even though we have online monitoring system, so we need to check the online monitoring system to ensure that the parameter displayed on Cortex TM4 are under our design parameter or not. And in the future, if you want to have the full option of online monitoring of power transformer, need require some sensor such as Concession TM for online analysis of multiple gas to eliminate routine oil sampling for power transformer. Sensor of on-load temperature to monitor the position and number operations remaining in service. And the last one is TSVM to measure capacitance and send data by online monitoring system. Reference. And lastly, thank you for your attention. ขอบคุณครับ สวัสดีครับ